Okay, so we're here looking at a fractured, broken, fallen marble tablet that was initially set into a socket base, a base with a key, kind of keyway in it. And so this is the stone initially when it was installed is basically a tenon, and the base is a mortise. And in this style stone, about a 2-inch thick marble stone. Sometimes these were called marble slab stock. These were very common all over much of North America. Unfortunately, they're quite thin. They tend to break very easily, especially as time goes on. Marble becomes more fragile, and of course, weather events, falling tree limbs, modern lawnmowers, and numerous other factors have contributed to many of these type of stones breaking. The base that it's set in, it's leaning a little bit. We can actually take the level right here, and really all that becomes relevant is not so much the angles of the base, but if the headstone portion, the tablet, is plumb or not. And just a little terminology, this is level, as almost everyone probably knows. The term for this is plumb. That's a 90-degree angle from level, and so we can take this level and put it on here, and we can see that it's leaning pretty badly. Now it looks like a good candidate to fix, to join with an adhesive, but so what we're going to do is just carefully raise up the fractured piece and then put it on top, and then make sure it fits together before we spend more time on it. Okay, it looks like a good fit, so it looks like a great candidate to repair. Provided it fits nicely together, we're going to then move it to the side temporarily, excavate a little, level the base, clean the mating surfaces, and then we're going to join the stone. Okay, so we're going to move forward. Now, you can do this in different ways, and you know, people use like plastic trowels on their hands and knees and different things, but I'll show you the way I do it. And I'm not going to touch the stone, but I'm going to come over here with a spade shovel, and provided I can get under it, well, if it's in cement, we got a different story going on here. So that's why we could have problems. So I'm hitting something hard, so now I got to see why and what's going on. So I'm hoping it's not embedded into something hard, and if it is, it's moving. That's a good thing. Okay, let me just try to loosen it up a little then. A lot of time I can just get under the whole thing with some of the soil, and it'll come up very easily, but because that didn't happen, I'm going to try a different technique. So I'm going to open it up carefully. Now, certainly we don't want to hit the edges. I'm going fast, but I'm very experienced at this. But okay, now I'm under it. Okay, I'm not touching the stone. There's about an inch of dirt between it and the shovel. Okay, and so it's not going to do any harm to it. Now I can get around to this side. Now in bigger stones, we're going to have to dig all the way around it. We're generally going to want to go sideways with this. Okay, just like I did. All right, now we can see that overall it's in pretty good condition. Bring it up like this. Let me just walk it back this way a little bit. Okay, so I'm right over here, and I'm gonna lay it down because I should have had this within arm's reach. But now this is a stainless steel brush, but I'm going to use it very lightly now. We would never use this on the exposed face, but on the mating surfaces, we're going to have to clean it pretty aggressively, and we're never going to see these surfaces again because these are going to be where it's going to be joined. I'm not going to use that kind of brush on the main face of the stone, and it looks like it's going to read the opposite way, so we may want to change the camera angles after we get this going. Probably would be good to have somebody give me a hand. Fitzy, you want to help me with this? So we can carefully dry fit this and not strain our back. Yep. Let's move this shovel out of the way. So we're going to each grab a side, and we're going to place it up carefully. We're going to spin it over. It's a pretty heavy piece of stone. And we're going to just place it on top here. This is called dry fitting. Okay, you can let go now. Now the base is leaning a little, but even so, we see it's a really good fit. It is weathered away a little from being, you know, in the ground for so long. I can feel loss right there, and we can talk about filling that in after, but it fits well enough to join it. If this marble continues to sit in the ground, it will get, the edges will get more and more rounded, as well as the upper edge being exposed directly to the rain and snow and ice and everything. And so it will continue to deteriorate in the ground and you know, become harder and harder to read as well. And so we have a good fit here, so let's take this back off, and okay, and we'll just bring it back here. We don't have to put it in the dirt. Grab one of those pads if you would, I'll keep it elevated. And we could use pads, but blocks really work really well. So we'll put this right here. Okay, so the next thing we're gonna do is concentrate on re-leveling this base. And so we can see that it's leaning backward. So what we're gonna have to do is excavate around it. And, okay, and hopefully it's not that big a base, but you never know, everyone is different. Actually, what I'm gonna do with some of this excess, at least temporarily, is put it right in the depression. We can always pull it back out, but ultimately that should also be filled in, or the mowers will tend to be, you know, settling into there when they come over it. So this side, we're not gonna hopefully have to do anything, but I'm gonna relieve the pressure because it'll act as an earthen dam to prevent us from plumbing it. So I'm gonna, okay, what happened now, okay, this is a delaminated base. We're gonna work around it, but there's an issue here already that I see. And so the base, the lower base actually delaminated along a bedding plane. And so being that it's underground, we can work on just realigning it and leaving it alone like that, but it actually has delaminated, which is unfortunate, but it seems very common with the limestone in this region. Because it's not that large a stone and gravity goes down, it'll still be fine to reset it the way we're doing it. But just to mention the fact that it has, wow, something big is right here. That's interesting. Rock. Not sure what is going on there. Okay, looks like a big rock. Wasn't expecting that here. So we want to get under this base now. Now we could theoretically join this while it's leaning. That's not a good practice because it'll be stressing the joint the whole time and it's more likely to fail. So usually we want to plumb everything before we join it. This base is bigger than one might think. Wow, that's the bottom right there. But that shows you that there's a lot of digging just to level a small, what appears to be a small base. The other thing is a lot of settling has occurred.
How far does the tenon go into the base?
The tenon varies in how far it goes into the mortise, but most commonly on a stone like this, about 2 to 2.5 inches would be most typical. Then normally, well, there's some different ways they were installed. But like a mortar, historically more of like a lime mortar, some hard rock here. I'm not sure if that was added or what's going on actually, but or that's part of the base. Yeah, the whole, okay, there's issues going on here. So that's why I said that it may not be the best example. And so, I don't know what you want to do, but I'll show you what's going on. It's delaminated along a bedding plane. And so, I didn't expect that. And it's also shifted a lot because of that. So, I guess we could just skip this part and level this and go on. But this is not ideal. There shouldn't be. So you can see how it delaminated though. It's interesting to note. You see this a lot on stone from this region, but I'm not sure what to say about that. This has happened a long time ago. There's a lot of dirt in between the pieces. And so when the limestone was formed, there's a lot of weak bedding planes. And then over the course of time and with rising damp and freeze thaw, so I can see there's multiple delaminations now. And so that's exactly why I wanted to get into it and see what we had here. So it's better. I mean, I guess I can just level this top portion for demonstration. I mean, it'll still stand, but it's not ideal. So this is what I'm trying to, you don't know what you're gonna find underground till you get into it. And so, so what is the solution for this? If the lower base is disintegrating, the best solution is to make a new base. And ideally out of natural stone, that would be very expensive. The simple solution is to cast a concrete replacement base. However, with one large distinction, we can use modern concrete like that, but we want to create a keyway. And so we don't want to puddle the stone into wet concrete. And so we could either make a simple form here, or we could do it like in a garage or indoor space. And we want to just cast a base, and then we can use rigid foam insulation to create this outline. And generally we'd add a 1/4 inch all around so that there's some leeway for a mortar to go in there. And we want to use a historic pointing mortar, which is going to allow expansion and contraction more similar to the hardness of the stone. So anyway, we'll just kind of fast forward through this and level this a little so we can go ahead and join it. And once it's all put together, it'll be pretty stable, and we'll regrade it and everything. So it's just not ideal, unfortunately. So that's actually plumb right there. This side is leaning, but I probably better to leave that alone because it's going to be a problem if I start to raise that angle. So front to back lean is going to be the issue that causes breakage. Right to left is what you think of as like a cartwheel, is generally not going to cause anything to break. It's more of a cosmetic lean. So what I'm going to do is just go ahead and fast forward through this. And that's why you don't know what's underground. That's why it's hard to be sure what the process is going to be exactly until you get into it. Because I thought this looked like a solid base, the lower base, and we could work with it. But what I'm seeing again and again, this limestone from this region has a great propensity to delaminate, and that causes a lot of issues here. Okay, so
how would you get it out if you're going to make a new cement base?
I can pry the whole thing right out. If I just dig around it enough and use the bar, we could.
I mean the actual tablet thing coming up.
Good question. Very good question. So these vary. Sometime you'll find them, and there's an example right over there that is loose in the keyway. But if they are bonded in tightly, that's a very good question. But if we took this stone here, this piece, and turned it upside down so that this part is on the ground, and then we gently tap this toward the main body of the stone with this weak stone, it'll probably start to crack off. We could also take a hammer drill and like perforate it to weaken it. Certainly on the ends, that would help a lot. And but that is a good point, and very good point to make, that we would have to remove this first. The other option, certainly, and I've done this many times also, if there was only one area of delamination, we could clean those really well and then join those with a mortar. I would use a mortar underground always, because other adhesives are not going to perform well underground over a long period of time. So anyway, we're going to just go ahead and quickly regrade this so we could do the joining. Not ideal, but it's going to be up, and it should be fine. I mean, it's not going to fall over, and but the base should be a solid one piece underground. So unfortunate as it is. And so unfortunately, this local, and it's not unique to this region, and I'll just say that I see this all over the country, that I've worked on a lot of bases, sometime on big monuments that have deteriorated like this, and sometime, you know, above ground and underground. But it was a very common practice in the late 1800s especially, and probably into the very early 1900s, to use regional material for the lower base on bigger monuments. And so, for example, in Kentucky, I see a lot of Kentucky limestone. In Connecticut, we had more sandstone, so most of the old ones are sandstone. And so on and on in different regions, we see different quality stones on the lower bases, and so that can be develop problems later. It all depends. And it's not like they knew that the stone wasn't going to last. And so there's just so many variables that it was hard to predict. Okay, so I'm going to just quickly clean up this area so we can concentrate on prepping the surfaces and joining it. In fact, I should just stop this for a second and come over here and clean this so it can start to dry. And we're hoping that the weather holds off for a while. But actually what I'll do is take this brush and this sprayer, thank you, And all I'm going to focus on, actually I could use that, that brush. I'll give it a quick cleaning, and then I'm going to mainly just focus on the broken area, and I want to do this ahead of time because I want it to start to dry as much as possible. So I'm just going to give it a quick cleaning. Okay, this would benefit from a cleaning with D2 also, because it was, on this side at least, there's biological growth. On the back side, it's going to be all mineral staining, and mineral staining is much harder to remove. It's not biological in nature, so you can't just remove it quickly. It tends to get in the pores of the stone deeply, and it's hard to clean. We can poultice it out. Eventually the sun will help with successive wet-dry cycles from rain and sun, and so it'll tend to clean over time. We could clean these pieces separately, but usually what I'll do on repairs more oftenly is do all the repairs and then do the cleaning later once it's all repaired and upright. Okay, so I'm going to go ahead and go up. I'm just going to get the heavy staining off. Looking good. You can see that all that ring, that's all biological. That's more like a kind of a lichen, algae, and then this is more of kind of a mold. There's probably also some mineral staining mixed in, but this was this part visible. Okay, so the back, see, that's where we're going to have this mineral staining I was just discussing. I'll just give it a quick clean so it's easier to handle. And then I'm going to concentrate on cleaning the mating surface on both pieces. And then while that's starting to dry, I can go ahead and regrade. Okay, so this is, cleaning a lot of the heavy soil off. However, it's going to stay stained on the back for a while. There's no easy way to remove mineral staining on a marble. And no matter what you do, it's going to take some effort and time. A poultice is something that's often used with problem staining, and a poultice can be made in different ways or bought as a pre-made kind of product. And a poultice is something, it looks more like plaster or paper mache, and the principle is you would cover the whole stone with it where you're trying to clean it. Leave it on for a period. The dwell time is how long it'll stay wet. Sometimes poultices are also wrapped in plastic to extend the dwell time. But then eventually the idea is to remove that plastic and let it dry. And then if a poultice works effectively, the principle and the hope is that when it starts to dry completely, it'll draw the staining out of the stone or the substrate, whatever you're trying to clean, and it'll draw it into the poultice, and then the poultice can be just removed, and the stone hopefully will be cleaner. So, okay, so I use the stainless brush, but only on the flat. Okay, I don't want to round the edges at all, so I'm never going to clean the face of it, even though it would work very quickly. I'm only focusing on the broken, fractured area. And the reason why stainless is okay is it'll clean it more quickly. And if there's any little flecks of stone that are loose, then we want to remove those so we get a better bond anyway. Okay, so that's looking pretty good right there. It's pretty well cleaned. So you could use that paper towel there. And I'll lay this back down and we'll work on the other side. Okay, we can put this here. So it helps if we blot it out a little. It actually speeds up the process tremendously. And so I'm just going to get it started by just these blue paper towel, very absorbent. And the stone will change colors. We could also use, if we had a heat gun, and we could use that like a hair dryer. But there's no cordless version of that tool yet, unfortunately. The power demands are too great. Just a blower, like a portable blower, will help push some air on it and speed up the process. I will say, if it's a sunny day, then this will dry very quickly, and you will see the color change as it dries. Depending on what adhesive we use on this, we want it to be, in this situation, drier is better. So we want a clean, dry surface. And so I'm going to just kind of get this going here. And And it's pretty good now. It's pretty clean. You still see a little staining. We see mineral staining here, and then a little bit of the kind of algae staining, but I wired brushed it twice, and so that's kind of under the surface of the stone. That's not going to affect this joint, and so we'll just let it kind of continue to dry for a little while. I'm going to keep it out of the ground right now. It's elevated on that pad, and so we're going to do the mating side right now. Not sure if I can use this handheld sprayer just as well. And now on here, there's a little raised lichen. There's a lot of like kind of mold on it. And so we're going to clean this area up as well. Not necessary. Usually I'll clean this like this. This is much more aggressive. And then after the whole stone is joined together, clean the whole stone with D2. In a workshop setting, a lot of time, then certainly this piece could be separately cleaned. We could clean all the pieces with D2 also. That's not harmful. But then you have to roll it over. It's harder to handle. And so when I'm working in the field, this is exactly the way I'll usually do it. And I'll do the major, I'll clean the whole stone after, because there's going to be another level of work is we're going to have to infill the loss on it, because there's like areas have chipped away. And so those, there's lost stone. Okay, so I'm going to rinse this now. You can see the little sprayer works fine for this as well. That's looking really good. Okay, so take this brush and just get a little bit of this mud off of here. Rinse this a little more, just so when we handle it, we don't get all dirty. I'm not getting the area on the bottom wet again. Okay, so I'm going to come over here and get this to start drying now. Okay, so that when a stone breaks like this, it's called a fracture, just like if you break a leg, it's called a fracture. And when the piece is broken off, it's called a fragment. If it's a small piece or a big piece, it's generally just referred to that as that. Sometimes they break into multiple pieces when they fall. Certainly if they hit another piece of stone, like a marker or something nearby, it's likely they'll break up into multiple pieces. So I'll just shut this off. And so this is drying up nicely. So. What are we looking at?
Just below your fingers.
So that's running through part of the stone, but not the whole stone. We could potentially try to do some mitigation after the fact to try to reinforce that, but it's still structurally sound. So that's more of what it is. It's really not open, it's just weathered, so that would be considered a hairline crack, and it's not radiating through the whole stone. It's mostly not visible in the front. And so unfortunately marble tends to crack a lot. Things like the Tomb of the Unknown Soldier, just through the forces of the marble moving, through hot and cold, wet and dry cycles, over the course of time has developed hairline cracks like that. And marble oftentimes tends to do that, but it depends on the geology of the stone, and it's very difficult impossible ultimately to accurately predict if it's going to develop hairline cracks later. Marble also is unusual in the fact that if it's not supported well, equally it can warp over the course of time. And so like a stone like this could actually have a bow in it. And if it's been sitting on the ground for a long time, then it can get a big curve to it. And so sometimes there's table-style monuments or box tombs like that if they're not well supported, and they would use a slab of marble on the top on a horizontal surface, then those are more likely to warp. And so when they do warp like that, then they will tend to develop a lot of hairline cracking on the opposite side. And so they become very compromised. And so that's another challenge that we can see. But to back up a little, if this wasn't allowed to lay in the ground for so long, then these edges would be cleaner, not just from dirt, but I mean they would be sharper edges. And so one of the ways we can test and see how likely it is that it's going to fit together well is just how sharp the edges are. And if something broke, like a tree limb fell on it and it's been only a month or 6 months, it'll use really sharp edges. And so then they'll fit together really nicely. Sometimes there's still chippage along the edge, but they'll tend to be really sharp edges. I'm going to just leave this on here to kind of blot it out a little, and now we'll go ahead and regrade, and then I'll come back and talk about the joining process. So we'll try to get the grass on the top. And again, I'm kind of rushing today, but we could put down tarps and we could separate the grass certainly, and that would help with the cleanup effort. But I'll end up with a nice end result here regardless. So pretty nice soil here actually. Certainly pretty easy digging. But the soft soil that's easy to dig also has a lot of settling many times within it. The stones tend to sink more easily. The big rocks in soil can cause that issue too, with frost heaves especially. And sometimes the stones get uplifted from frost, and in other times they settle underground a lot. The cemetery we were at yesterday had a lot of settling occurred. It was very soft. I would call it alluvial soil, and this is pretty similar soil actually in certain respects. Okay, it's looking better. Tamp this down. Certainly this chunk of rock is not going to be going back in, so we'll dispose of that after. And we'll bring this back toward the stone, see how much of this we use. If we have excess, we'll remove it and fill in a sinkhole or bring it to the dirt pile. Okay, still low in the back here, so I'll just finish the regrading process. And take some of these clumps and just bring them right over here, save time. Okay. It's like a library. So quiet. Nice quiet spot here, a little off the beaten path.
How big of a gap would you say when you say you can't just mate them like that? This is a good one. Is it like a ½ inch in a couple places between the two stones or fractures?
It's not so important how big if there's chunks missing, as long as the main part of the stone will mate together well so we can join it. And so that's why we dry fit it and test ran it. And so we can fill in loss after in a number of different ways, but we need the pieces to fit together. And so if it's been broken for so long, and the other thing we want to make sure, sometime there's another piece that's missing. There could be another piece, and sometimes it looks like it's going to fit and you put it together and it doesn't fit at all. And so that's why we always, before we spend a lot of time, we want to make sure and just quickly dry fit it if possible and make sure that the pieces are going to fit together. And you know, overall, so again, we can fill in loss with a mortar, or we can composite patching material. They would kind of specially made mortar for that. Depending, we can also make infills in certain instances with a clear UV stable epoxy, and we could add a lot of marble aggregate to that, and we could then do fills that are targeted and still be very structural. And so it all depends on the specific stone. Okay, so we got this all cleaned up. Okay. And we're going to come back and talk about joining it now. If there's extra, usually best on the back, if there's just a little extra. I don't like to berm an area around a stone. A lot of people like bank it up against the stone. We don't want to do that. We want it to flow with the landscape of the cemetery. Looks like actually I need a little more there now. It's settling. And we actually filled in that big depression from the soil we dislodged, so we kind of needed to do that anyway, so it worked out well. And it still could use a little more topsoil. Probably it'll tend to settle a little, especially when it rains. We'll come a little more with this, bring a little bit around the front again. Looks like we're just about the right elevation too. Okay, I'm just giving it time, a little time to dry as well. So a lot of time it's best to do prep and do a bunch of stones. You can see that's dried out pretty nicely now. But we could, if we have a few fractured stones, we could come ahead and prep a few, then come back and join a few. So it's like a little, even if you're working alone, makes it a little more like an assembly line. And certain things like the excavation here, it gets muddy, but we could do this in a little drizzle. We don't really want to do the joining in those conditions. So different days might be better suited for different aspects of the work. So, okay, so we're looking pretty good. Just gonna finish the regrading out a little and just call it done for now. Okay, looks reasonable. And we could just pluck a couple of these bigger pebbles out if necessary. And pretty much, I think if we threw some seed down, it probably would take here. It looks like pretty good soil. Okay, looks good. So we'll move on. Now we already dry fit it. We're not going to do that again. It'll only fit a little better now that it's nicely cleaned. So we're going to go ahead and move forward with the next step. Okay. Put this aside. And I'll get a pad to be on, and I'll get the supplies I need. Ready, in position. Okay. Don't really need this anymore. Actually, we'll just clear this working area. And we're going to need these things right here. And that's about all we need. Okay, so I'm going to come in here like this and talk about epoxy now. So there's many different kinds of epoxy, and there's many pros and cons to using epoxy. But on a fractured stone like this, it's really the only good solution, in my opinion, to fix a stone like this in a practical nature. Now, I will say there's different philosophies on doing this work, and there's different ideologies. And I'll say also, if you ask, say, 5 or 10 lawyers or doctors or accountants, they could all give you different information. And they all can be professionals, but they might have different opinions. They're coming at it from a different place. Conservation is no different, okay? So if you ask different conservators, you'll get different opinions on things, and that's okay. But what I provide is the best reasonable solution to the problem that I know of, and I've been doing this full-time nationally on historic stones for over 20 years. And so also, I'll just mention that I work at a lot of sites repeatedly because it's very actually important to think about this, that it's not like a building. You might do deferred maintenance and do a big restoration after 30, 40, 50, 60, 100 years. Graveyards have constant needs. I'll say cemetery. We're in a cemetery. The technical difference is very blurred, but people use the words pretty much either way. But this is really more of a cemetery from the era and the style. This is a gravestone like this, though, could be in a graveyard, which tends to be a churchyard, which kind of was more in the colonial times. But anyway, some people think you should drill holes into stones and add pins, and that is a valid method in some situations. My personal opinion on a 2-inch thick marble stone, you're going to weaken the stone more than you're going to add strength. It's very brittle, and certainly if we were going to drill into this, we could definitely not use a hammer function on the drill or it will disintegrate it. Additionally, if we're going to drill and pin, we have to align these 2 holes, and it's not a perfectly symmetrical edge. Then the next question is, how big of a hole would we be drilling, and what would we actually put in the hole? And so we definitely don't want to use a ferrous metal. That's a metal that'll rust and expand, and that's called rust jacking or metal jacking. And so there are other options like stainless steel or high-end fiberglass, but again, I don't recommend drilling or pinning a tablet stone like this ever, because I think it's going to be more harmful. Now, if it's really diminished and it's not going to have the structural integrity to hold up, then we could add channels up the side, which would be visible. You could do that in stainless steel or in aluminum, but again, I wouldn't use a ferrous metal. Or we could add a backer stone to it, but that's a lot of extra work. But there is a point when the stone might be beyond repair, at least with simple methods, okay? So you have to make a judgment call in the field. And so that also, if you have a lot of stones to work on, then you should, decide, is it likely to last for a long time? Because otherwise it's putting good money at bad, as they say, or, resources into something that won't have good longevity, okay? So to me, this will have good longevity based on the way I'm going to do it. It should last a really long time. So anyway, moving forward, we're going to use this epoxy. Now, there's many epoxies that are made today, and most of them are not going to be really good for this, okay? So this is a very specific adhesive, and also, as I mentioned earlier, a lot of people in the field compare notes and use similar products that tend to have really good efficacy and have good durability. And so this particular adhesive, I've been using this company for about 25 years, but this particular adhesive I moved over to about 15 years ago. But many other people like Jason Church and Rusty Brenner in Texas and other people who also work professionally in the field use this exact same adhesive, okay? So that's not to say there's not others, but again, I just want to make the point that when you have something that works really well over a long period of time, I am leery to switch to something that is unproven. Okay, so that's where I'm coming from on this. And so, but this particular product we're going to use the company is called Akimi, and the particular epoxy is called Acapox 5010. Unfortunately, at local home centers, generally, from my experience, and I've been traveling around the country for 20 years, and occasionally have run out of supplies and tried to get things locally, it's very hard to find alternatives that work out well. And also, they sometimes have very small sizes, and you'll get just a tiny bit out of a little syringe-style epoxy. And it might be good for fixing your jewelry or a small project, but not necessarily for this application. Okay, so what I'm going to do is just use plastic spoons, and a lot of time I use paper plates. I have bowls here. But any epoxy is going to have to be mixed, and it's going to start a chemical reaction. It's going to cure. This epoxy is a 2-to-1 ratio. So if you purchase this, you get these 2 tubes. And so it's 1 part of this to 2 parts of this. We can measure this by squeezing little lines out. We could actually weigh it. This actually can be done by weight or volume. And so it says it right on the label. And so what I'm going to do is push it out of the tube into a plastic spoon, just like this, okay? And I'm going to squeeze it out. And I'm going to do it by eye, so I get about the same amount in 3 spoons. So I did 1 spoon there. It's viscous, but it's not a heavy viscosity to it. And so what I mean is I always liken these things to things that people know. So this is about like a mayonnaise. Okay, there's other epoxies that are more viscous, that are more toward like a peanut butter. And then also I use an epoxy putty in other situations that's more like a Play-Doh, and it's much thicker. Okay, so that's 1 part. Now we're going to go to 2 parts. Now this is also available in cans that are much larger and a better value if you're doing a lot of work. So then I'm going to squeeze this one out, okay, and by eye about the same amount. Slightly heaping, but every edge of the spoon is not filled. It's by eye, so that's pretty close. That's a 1-to-1. Now I need 1 more portion to make a 2-to-1, okay? Now this is a clear epoxy, so it's very hard to tell that it's mixed. They actually make pigments that go with this that are little, they're in little tubes like this, but very small. And there's actually 8 standard colors that are available as a set or individually. Like black and white would probably be the most common, because if you were working on a gray marble, if you wanted to, so if anything squeezed through the surface, we try to avoid that, but sometimes it happens. One of the things about this particular adhesive is that it doesn't yellow when it gets hot sun sun on it. That's called ultraviolet, and generally most adhesives and most epoxies yellow. And so if there's a line that comes through, then you'll get a yellow line, it'll become unsightly. So this has incredible durability outside, but it doesn't get that yellow line. Okay, so I'm gonna go ahead and mix it. So I'm just gonna push one part off the other. It's kind of probably hard to see what I'm doing. And I'm just making a small amount. And so you don't need a lot, that's the thing. And so I'll just put this on here. Okay, and I'm gonna go ahead and mix this up now. Okay, you should wear gloves when you do this. You don't wanna get this on your hands. Okay, so we just mix it for, I don't know, maybe 30 seconds. It's not really that much. Just to make sure it all gets well mixed. Probably a good idea to take one of these spoons now and push this off of here. We don't have to use spoons. We can use different things to do this, but I've found this works well. And they're disposable. And so we don't need a lot of adhesive to join a stone like this. Okay, that's good right there. This is now pretty dry. You can see the color has lightened up a lot, and it's the order we did it, and the weather's cooperating. And so I'm going to come over here now, and I'm going to apply this. I'm going to apply it down to the center of the joint, and then I'm going to work it away from the center of the joint. And I'm going to want to keep it I'm not going to want much at all close to the edge, because that will tend to squeeze out. So we're trying to avoid squeeze out. We're going to generally go on one side only, unless there's some specific situation, there's a lot of loss or something. But generally we're going to just put the epoxy on one side. And then we're going to join the stone, and then we're going to make sure it's well aligned, clamp it, and then we can look at where there's some little chips missing and loss, and we can talk about that next. So I'm going to move this around, and I mixed up just enough intentionally because I didn't want to waste any, and I have plenty here. And so I'm going to just move this around a little. We can use other tools. Again, we can use little tuck pointers or tongue depressors, or you know, this just works well for me to apply it and move it around to where I want it. But there's no one way to do this. And okay, so it's almost getting to be everywhere I want it. I'm just going to even it out a little. I want some little bit of high spots, so it's not perfectly even everywhere, so I make sure I have really good contact. And still a little more in here. Put it on here, move it around a little. Getting really close to being ready to join it. And we're just going to place it back on top just like we did originally with the dry fitting. And then we'll just make sure it's well aligned again. And then we can move forward to the next step. But that's about it. It's pretty evenly spread out. So if we were fixing a gray marble like we had cleaned initially, if we were joining something like that, if we put just a little bit of the black pigment in, we could turn it into a gray, and we could get a really close match. Just in case a little squeeze to the surface, then it would be a better match. But it is clear. However, if you leave it dry on the surface, you will get a sheen, because it'll end up being more of a shiny surface. So it won't yellow, but still we want to avoid it of getting on the surface. That's pretty good right there. If we do get it on the outer part of the stone, we can clean it off quite easily before it cures and hardens, and we could use an acetone, just a little bit of an acetone and a cloth or a brush, and we could then remove it. But the idea is to be neat and not need to do that as much as possible. So what I'm going to do now is take these gloves off, because I probably got some adhesive on them, and then we're going to go ahead and join it. So we're good to go now, if you want to give me a hand again. And we can go ahead and just put it in place. I'll get these slats and clamps ready for the next step. Okay. So we could go ahead and, so put your hand in so we can just, yeah. So, okay. So we're going to be facing the other direction on this, unfortunately. Camera's on the other side. Yep. The pretty part of the stone is reading the other way. Okay, and we come down low now, and we know it's a good fit. And fortunately, it's all right, you can let go. Fortunately, marble tends to break perpendicular to the vertical. Not all stone does that. For example, slate, which was really common in some eras, in some areas in the colonial era, tends to break at very odd angles. So it's really good fit on the front. There's a lot of loss on the back, okay? It looks much better on the front, and it would probably make sense to get an angle on the front, certainly, because it's very photogenic also. The stone has a really nice carving in it. And also the water that was sitting in that carving for so long was also not good. But anyway, it's a good thing that it does sit here on its own. There is a lot of loss here, okay? And so that is from it being in the ground for so long. But it does stand on its own. So now we're gonna brace it and make sure that it can't accidentally get knocked over while we're finishing to work on it until the adhesive cures. And so we're gonna use bar clamps. And we can do this on each side if necessary, but I'm gonna put a couple slats of wood, and these are like 1/2 inch thick by like about 2 inches wide. I'm gonna use bar clamps. I'm gonna put one on each side of the brake, just like this, and bring it real tight. And then I'm gonna do another one on the top of the brake. Okay? And now it's well braced. This will keep it aligned. It didn't really move. Another good practice is to stand up and sight down and make sure that it's basically plumb. It looks really good. I'll put another pair of clamps on the opposing side for safety and to keep it aligned. They don't have to be as long. They just really have to bridge the brake. And this one is bent, so I'll get another one. It's got crushed at some point, so want nice straight pieces. Little slats of wood again. And we could take these off as we need to when we're doing other work, one at a time probably, and that way we won't have any issues. And so how long will this take to cure, and how long do you have to leave the clamps on would be the next question. And it's going to depend on the temperature outside and the weather conditions. Also, the ambient temperature is not necessarily the same as the stone, but in like a 70-degree indoor kind of climate, this epoxy, you probably have about a 20-minute working time and probably about an hour and a half approximately cure time, maybe less. So it's not a fast setting epoxy. But if it's very sunny out and very hot, or there's a big breeze and sun, it can start to cure much more quickly. So there's a variable curing rate. Now, if the temperature goes down to like 50 degrees, you probably don't want to join things below 50. But if it gets down to like 60, 55 degrees, it'll go much slower. So it could take many hours. But as long as it doesn't freeze, it will reach the same hardness in the end. But if it's a time of year when the temperature is going below freezing, not good for doing this work. Or it's better to do this earlier in the day while you have the sun, and give it time to cure before it before it gets too late in the day, and usually it cools off at night. So that looks really straight, it looks good. So basically that's a good repair. That's the main part of joining it. And so, so I guess any questions about that process would be a good thing to touch on at this time. Since there's
mix up some more and then use a wooden tongue depressor to fill in?
I'm going to use tools like masonry tools to do that, but I'm not going to. But yeah, there's a kind of a bunch of different options now, and we could do a couple of them. So actually, probably a good option on this would be to use, because there's so much loss here, it's very structural. And so if we first of all, if we're going to use a mortar on this, or a composite patching material that is a cementitious based material, we don't want to use a gray or a hard Portland cement. And I'm not going to get into a whole discussion because it's too complicated in this simple demo about different options. But if we're going to use anything that's cementitious or cement based in any way, this epoxy needs to completely cure. So we can't do anything to it right now. The other thing is that if we're going to use materials like that later, we want a damp surface, but we want or to be solid structurally. But those type of repairs are not going to add a lot of strength. So we'll use we're going to use the same material we just joined it with, and we'll add the marble aggregate to it, and then I'm going to use tuck pointers, and I can fill in this gap, and that will be structural, and it'll be largely marble and just enough epoxy to hold it together. And so I'll go through that process in a minute, but I'll have to just break for a second to get the materials. So any other quick questions?
What do these two tubes cost about that size?
The cost of this epoxy? It's about $50 for that much. I only used a tiny fraction of it, so you could do a whole bunch of stones. But the bigger cans are a much better value. It is an expensive epoxy, relatively speaking. We have other less expensive, many epoxies. I have 5 different companies. This is my personal choice for this because I think it's the best performance, and that's why I recommend it. But there are other options as well. But again, you don't use much, so it's going to go a long way. And so we used a tiny bit. I mean, we might have used, you know, a few dollars worth. This is marble. We can use this on any stone, yeah, on any stone. And just a couple things to mention about this particular adhesive, the Acapox 5010 from Akimi. It's a very pure high-end epoxy, and so because of that, it has virtually no VOC, which is volatile organic compound outgassing, so it has almost no odor at all, and that's more relevant to indoor applications. Additionally, it is one of very few epoxies that is food safe after it cures. We're not eating off of this stone, but it is a very common adhesive to be using on high-end kitchen counterwork that's oftentimes done in granite, because after it's completely cured and hardened, there's no transfer of anything. It's designated as safe for food contact after it is cured. Very few adhesives have that designation. It's not relevant to this, but anyway, that's just something to be aware of. So that basically will finish this part of it. We'll do a second little phase on the infill, and so we'll just break for like a few minutes right now.